Hello. Does this go forward? It does. A little spoiler for y'all. Hi everyone, I'm Dave Kirk. Today I'm going to be talking about something that I got to build a few years ago. I was brought onto a company to basically build their entire infrastructure, which is like a really, really good thing to be pitched to you in an interview. And so prior to that, I had gotten the good opportunity to build just development infrastructure for a company. And so I want to talk to you all about some of the stuff that I built for my previous employer that I think was some really, really solid development infrastructure, environments, etc. So we're going to talk about the core problem that we're trying to solve, which is basically how do you develop a lot of microservices in a clean and nice way. We'll talk about what a hybrid development environment is, which is sort of the solution that we came up with, how we went about implementing it, and like some maybe opinionated advice on how we went about setting up our builds and deploys and everything, and some practical considerations if this is something that you think you might want to do. Some stuff about me real quick. I started programming in Second Life like 15 years ago. Has anyone else in here ever written Linux scripting language? Yes, my man, excellent. I've been working in DevOps since I started my career. Lucked in, like a guy who ended up becoming one of my closest friends, pulled me onto a DevOps team, and I've been doing it ever since. If you want to get in touch with me, d@vidkirk.com. I came up with that email address at uni, and I thought I was very clever. You can also reach out to me on LinkedIn, David Kirk Jr. If you just go for David Kirk, that's my father. He does not know as much about Kubernetes, but if you want to talk about baseball, that is your guy. I currently work for Wayve. We're trying to develop self-driving cars. It's a cool company. We have a chef, and we are hiring, so if you're interested in that, talk to me after. But this is not anything about what I've been working on at Wayve, and just to be clear, any views or opinions expressed, it's mine. So the core problem that we're trying to address here is microservice development, right? It's hard. If you've got dozens of services that you are developing and needing to deploy, there's a lot of challenges for setting up effective and like useful, clean development environments for this problem. To start off with, computational overhead. You're way better at making your computer slow than Intel or Apple are at making your computer fast. And that's basically always going to be true. There's the cognitive overhead of how do you go about deploying dozens of services in a way that just makes sense and is easy to grok. Then there's the organizational overhead. The classic, like, this worked on my computer situation. You need to have consistent development environments. You need to have them ideally be production-like, and you need it to be easy for you to share your work with other people so that they can see what you've done and that you've done it correctly. Some common solutions for this that you might see, bare metal. If you're just running dozens of services directly on a machine, you're going to have inconsistencies across your organization. People are going to deploy them in different ways. They're going to be misconfigured. Port conflicts, other unpleasant things. There's complexity here, and you're going to be compute constrained. You can also do Docker Compose, which is better. You're containerizing things. You have a predefined way of deploying stuff, which is nice and better. But you're also going to be compute constrained, because everything is running on one machine. And you're probably not using Docker Compose in production, so you're going to have to, if you add a new service, you're going to have to add it in Docker Compose and then also add it in Kubernetes. And if you are doing Docker Compose in production, let's talk after. I want to make sure that you're okay. So, like, what do we want here from these development environments? We want them to be simple and fast to deploy for developers. We want them to be simple to maintain. For the DevOps engineers that are working on this. I really hate having to fight fires, and I'd much prefer to try to prevent them. You want it to be consistent across developers whenever they deploy these things, and you want these environments to be production-like. Sweet. So, the solution that we came up with for this is hybrid development environments. You start off with deploying basically everything up into the cloud. Everything that you're not actively developing, you chuck that into the cloud. Oh gosh, sorry, I think this is, I made some changes in between back then and now, but it's okay. I did improv for a couple of years, I can pivot. you basically just get it set up so that everything is deployed up into the cloud that you're not actively working on, and then whatever it is that you're actively working on, you run that on your local machine. You then set up some network magic to capture all the traffic that is going. You basically just try to trick the cluster into thinking that your laptop is inside of the cluster, and you set things up so that you can, from your laptop, talk to the main API up in your namespace. Or set it up so that things running on your laptop can talk into your namespace, and set it up so that things running in the namespace can talk down back to your laptop. For example, one of my coworkers, we had this piece of software running called Backstage, which was an internal website that we developed for like administrative stuff at our company. He deployed Backstage. He deployed his namespace set up to be able to intercept traffic. He ran Backstage on his local machine. Everything except for Backstage was running up in the cluster, and it's all deployed sort of production-like, so we had public ingresses available. He was in Denver, I was in Chicago. I was able to, from my laptop, hit the public address for Backstage. The traffic was rerouted from his namespace down to his personal laptop, and I was able to hit a breakpoint that he had set on his personal laptop from the public address. It's all deployed production-like, all very smooth and nice and cool and fun. Yeah, it's production-like. There's less toolchain and config work with this, which is really, really nice. I only have one toolchain that I was maintaining for this, for all of the deploys. It was sweet. Everything was deployed in exactly the same way. And the nice thing about this as well is the developers are exposed to operations work day to day. All of their stuff is running in Kubernetes. It's all in exactly the same environment that staging and production is running on. So as they're doing development, they're learning how to maintain production, which is so nice. I hate waking up like to fix issues. That's their job. It's not mine. This is a diagram. So basically, we had a bunch of different developers that would have their own namespaces. You would basically just deploy stuff into your namespace and run stuff locally. Networking magic would be able to connect to your laptop into the cluster. There are some challenges with this still. You know, it's easy to say just throw it all in Kubernetes, do hybrid development environments, it's fine, it'll be easy. But there's still complexity, like how do you build all of this stuff? How do you deploy all of this stuff? How do you connect back and forth? And with all of this complexity, one of the important things is that we wanted to try to simplify the tooling as much as possible. Just create common tools, create common workflows, and only introduce complexity where necessary. We also want to, again, simplify concepts. Like, the more workflows the developers have to think about while they're doing development, the more that they're focusing on how they're doing development as opposed to the thing that they're actually writing. And so you want to minimize the number of workflows that they have to worry about, the ways that things are getting deployed and managed, and minimize the cognitive overhead that they have to do and think about to be able to do their work. So for building and deploying, it's nice to build complex systems. I really, really like it, but ideally just focusing on basics is cool. We would have a single entry point. There was a tool that we used called Scaffold that was developed by Google. It's generally like pretty good. It basically just allows you to configure all of the stuff around building and deploying for different environments. So you can basically just run scaffold build and tell it to build an environment and deploy to an environment, and bing, bing, boom. It's got all the configuration in there. And we would use this exact same thing for dev, staging, and production, and just have different configurations per environment, like I just said. A single build and deploy path was very nice. We talk a lot about, you know, pets versus livestock in our infrastructure and having things being immutable. Treat workflows the same way. Reuse the same workflows between different environments and stuff. I keep on saying this. Minimize cognitive overhead. Reduce tooling development workload. There were 2 of us that built all of this stuff and had to maintain all of this stuff. And like, that is a lot to have to worry about. Give me a call, that's nice. You need to have okay, so we had a single build path here. When we ran builds, there was just one command that you would run to run a build. It would build, we had 30 different services. We didn't have a command to build a specific service. We had a command to build everything. And whenever you would build something, it would look at the Git hash that it was built at and then tag the resulting Docker image with that hash. It would check before building it as well if that Git hash had been built, so we never had to rebuild a specific Git hash. You can also, if something is like in the middle of work and uncommitted, just look at calculate a SHA of that file and append it onto the Git hash. And then you just have like a deterministic, meaningful tag for Docker images. Yeah, basically you just run one thing that tries to build everything, and you cache hit on basically everything. And it's the same thing with deploying. We, with Scaffold, generate the Helm for deploying everything every time, because you have to deploy the whole system to be able to trust that the system is working. We deploy everything, and anything that you modified, that's what Kubernetes and Helm would update. It's a lot like the trolley problem, except instead of having two paths, you've only got one path, and instead of deciding between pulling a switch to kill 5 people or letting one person die, or I guess other way around, you're building and deploying software. So it's not really like the trolley problem. Okay, so for our builds and deploys, we had one repo that all of our build and deploy logic and definitions were in, called a platform case, just defined everything that would be deployed into Kubernetes to support our stuff. This worked out pretty well. Like, ideally, you don't want engineers to have to write too much infrastructure code. Ideally, again, reduce cognitive overhead. But you don't also want to block them from being able to add new things. And so, like, having 21 of the 29 engineers at the time that I left the company having contributed to this was like, fantastic. And this is also just like a little bit of advice for probably the easiest thing to implement of this whole presentation. When you run a Docker command, it is sending in like a request to a REST endpoint, and you can change the endpoint that your Docker CLI is talking to. So you don't have to do it to the thing to the Docker daemon that's running on your computer. You can just have one really beefy machine that's a shared Docker daemon across dozens of developers. And when they run builds, it doesn't slow down their machine. When they run builds, they all have a shared cache. And if you point your CI workers at this same thing, then when your developer runs the build to create their local environment, if that same code ends up going out to staging, you don't need to rebuild it, and it takes a few minutes off of your staging deploy. Nice. For cluster interaction here, we use a tool called Tailscale. It is, I don't work for Tailscale, and I'm not getting any commission for this, but it's the best VPN that I've used. It's really, really solid, easy to set up, reasonably priced, easy to configure. We would use that to route traffic into the cluster. So basically, we had it set up. We wanted developers' machines to have access to the internal cluster traffic because we basically wanted to be able to trick the cluster and trick the developers' machines into thinking they were inside the cluster. So in Kubernetes, the internal networking primitive is a service, and services into the DNS address .svc.cluster.local. And you can set up Tailscale to resolve a suffix on URLs to a specific IP address. So we just got it set up so that it would resolve anything ending in svc.cluster.local inside of the Kubernetes cluster, granted access through the VPN to the Kubernetes cluster, and then every single developer, as long as you were connected to Tailscale, you had access to everything in the dev cluster, which was super, super smooth. And then we would use that, so that was for sending traffic into the cluster. To get traffic out of the cluster, like with that Backstage example, what we would do is instead of deploying the functional business logic into the Backstage container, we would just deploy an Nginx server that would route all of the traffic to the developer's IP address in Tailscale. And so just friggin' zoops things down and zoops things back up. And when Backstage is running in the cluster, it uses the .svc.cluster.locals, and when it's running on your local machine, it uses the .svc.cluster.locals. So you don't even have to change the configuration too much when it's running on your local machine. It's real nice. K9s as well, fantastic. We had all of our developers use K9s. It's basically just a wrapper around kube control, but it makes observing and interacting with the Kubernetes cluster so much easier. K9s is fantastic. Use this if you have people that are new to using Kubernetes. This is a really, really good tool. Hold on. Sometimes I watch. I got plenty of time. Managed services. You don't want to have to spin up a new RDS instance every time that a developer creates an ephemeral environment. It's expensive, but mostly it's time consuming. These ephemeral environments that we would spin up, it took between 1 and 7 minutes to build everything. And it took, I don't know, like between 2 and 5 minutes to deploy everything. And the feedback loop for this best case was under 5 minutes, and worst case was like 15 to 20 minutes, which was fantastic. And deploying RDS, it's slow. Deploying MSK, it's slow. And you don't need that level of resiliency that a managed service provides, so just chuck it in a pod. Data generation is very, very important for this. It's hard to get right. I found that this is one of the most challenging things in my career. I did work at a company whose whole thing was gathering data, so that was pretty easy. You basically just run the software and then you can generate all the data that you need. But for a lot of things, yeah, getting the good data generation scripts is one of the more challenging, but also critical things for making these stacks useful. Then third-party services, how you interact with them in these sorts of like ephemeral, hybrid developer environments where you've got multiple ones deployed. You want things to be production-like. Ideally, you want your developer environments to be interacting with third-party services, but most of them don't make it possible to really multi-tenant and do things in a like responsible way for your dev environments. So it's sort of on a case-by-case basis. So the workflow, start off with repo sync, which is a tool that we had that basically it looks, in platform case, there's a definition of every repo that we use. You'd run repo sync, it would clone the ones that you don't have, pull, get it up to date. You could pass in a branch to repo sync and have everything synchronized, prioritizing using that branch or main if that branch doesn't exist. This is the same thing that we would use on our CI workers as well. So when you deploy to staging or production, it just does repo sync to staging or repo sync production and pulls down everything that's tagged to staging and production. Make build dev, again, only one way to build everything and this builds everything. Make deploy dev and you pass in the thing that you want to intercept. And then you run the service locally and you do dev work. And it's ephemeral, so if things go wrong, just destroy it and turn it back on again. There were some pitfalls here, or at least like things to be aware of. With this sort of setup, it's really critical that everything conforms. Like, if you really are trying to minimize, like keep things simple, you need to force everything to follow through this path, or else you're just going to start branching off into all kinds of complexity. And you do have to be kind of strict about this, or at least I found that to be like a useful thing to do, especially if you're only 2 people. It's so much to worry about. The second things that are getting wrong and you have tons of fires to fight, it just sucks. You avoid that by being really strict about everything conforming. This is also unorthodox. Like, people are confused about what's going on in this when they first come in, and you have to explain it a bit, but it really, really pays off in the long run. Like this, it doesn't take that long for people to get on board with it, and it's so nice. Devs tend to be pretty big fans of this. Like I said, there's a bit of a learning curve, but it's not super steep, and you have this huge advantage of devs getting exposed to ops work on a day-to-day basis while they're doing their development. In the final year with this company, literally never had to step in to help out with production issues because all the developers knew how to interact with Kubernetes and deploy all this stuff. This was such a fantastic thing. I also did have a bunch of developers who, after they left, would send me messages being like, man, I miss your infrastructure. Oh, thank you, that's so nice. Having one tool chain is super nice, like I've said so many times. Reducing that surface area of tools that you're responsible for is very cool. And keeping your development environment production-like is just so nice for catching issues early and simplifying and reducing the amount of work that you have to do. And more than anything else, high achievers contributing to tooling. Like if you have good development environments that are easy to spin up, they are idempotent, and they are just like friggin' clean and make sense, it's way easier to get people who want to make the tools better to give them the ability to make the tools better. So this is like 4 examples of my coworker Yohei. He spent a week just on his own in his own dev environment building out data seeding that because everything uses exactly the same tools. Once he got that working, we had data seeding in all of the other environments, all the other development environments. Swaroop, one of our coworkers, implemented Kata for scaling, which is Kubernetes event-driven auto-scaling. Sick, I had forgotten that earlier. he was able to test out this new method of scaling our infrastructure in a dev environment, and then it worked with no issues going into staging and production because the dev environment was set up exactly the same as staging and production are. Basically exactly the same. Pretty close. And then yeah, Nick and Jordy, they added testing in these ephemeral environments, in these lower environments, and eventually they got to staging as gates for staging as well. So it's great. Like if you've got good development tooling, other people at the company who understand how valuable it is to build good tools are able to contribute. And that's pretty much it. Yeah.